All right, so we're going to talk today about climate and how that affects terrestrial biodiversity. That's what Chapter 7 talks about. But by that they mean that the driving factors here are going to be precipitation, and there's also going to be the temperature. And those things are going to dictate what kind of life can live in an area, and it's also going to dictate what the area is going to look like. And there's a lot of different places on this earth, that's for sure, and we'll get to talk about all of them in some pretty good detail here today. But we have very cold areas and we have very warm areas, and that's got a lot to do with the way things are set up on Earth, and we get to talk about that. Well, we're going to start by talking about wind, and that's a good starting point because wind is going to be involved in a lot of movement, and the way the wind moves is also related to the way water moves, and these two things are going to affect the temperature and precipitation as well. So wind is because the sun doesn't hit the earth directly, doesn't hit it evenly in all places. It's right above the equator, and in different places it's less sunlight. And because of that, there's going to be this flow, because things will flow from hot to cold and from high pressure to low pressure. Well, we'll talk more about that in a little bit too. But right now, this movement, let's talk about the importance of it, and that is that it moves, it creates the climates and the temperatures, but also moves nutrients around, moves heat from one place to another, hot to cold, and moves all sorts of things that are good for us, nutrients, but also pollutants. So we have to think about that, and we're connected in ways that we don't really maybe think about all the time. And the story at the start of the chapter is talking about how a large amount of dust, as you can see there, was really going across continents, across oceans. So yeah, we're all connected in ways we don't even know. Interesting to think about that in terms of pollution as well. We're all kind of connected in that way. Well, the weather is what you get. The climate is what you expect. That's attributed to Mark Twain, as far as I know. And that's the idea. The weather is the short-term deal, and the climate is the long-term outlook. So, again, I said there's uneven heating, and because there's uneven heating, when an area gets hot, it will then send, via wind, the heat will move to an area that is cooler than the hot area is. And there will always be a difference because of the uneven heating. And because of the rotation as well of the Earth, you get some wind just off the idea of you're on a spinning disk. So that's another one. And the properties of air, water, and land that they're talking about is this idea of the temperature movement from hot to cold and the pressure from high pressure to low pressure. Okay, so whether it's in air or whether it's in the water, we call these currents. And in the air, we talk about which way we can generally expect the winds to be coming from. Of course, the wind can blow from any different area, but there are winds that we can kind of count on and some circulation patterns that are pretty typical, so we know something about them. And we're learning more about this all the time. Still hard to predict the weather. There's so many factors, but we do know a lot more than we used to. Okay, so here they are showing winds here, and the winds that come off the ocean. So these can be moving precipitation as well, and we create waves. There's all different things involved with these winds that are involved. Okay, so the blue arrows are showing colder currents, cold air currents that are coming, being circulated around, and warm air currents are in red. Another thing about the movement here is density, because hot objects will rise because they're less dense, and colder objects, being more dense, will sink to the bottom. So that's another part of it as well. And we'll talk about that in a little bit. But these are the prevailing winds, the winds that we can normally be expecting to affect us. And of course, in the past they would take advantage of these things to find out when they would be sailing, and we still do now with shipping lanes and all of that. Okay, so here we have the uneven heating. So the sun is always above the equator at an angle to every place else. And that's a big part of how the circulation of the winds are going to go. And you can see the hot air at the equator is rising up in these cells that they talk about. And then the hot air at a higher altitude moves to a place that's colder. And as it cools, it starts to sink. And when it starts to sink, it warms up a little bit, starts heading back to a place where it's a little bit colder, and the pattern returns. Because as it gets back to the equator, it'll heat back up, and rise up it does. So this is the idea of the trade winds that we're familiar with here. And like I said, drove some of the boating, shipping lanes. Okay, so here's a little bit of a close-up of that as well. Okay, and so here's the idea of what happens around water here. So we could go around the cycle. If we start at the bottom here, we've got air, it's moist surface, it warms up, some of it is evaporated, so it's now water vapor, it's up in the air. This starts to rise up because it's hot, as it heats up, so it rises up, and when it does, it becomes more pressure higher up, and that's when you get the precipitation, and that high pressure moves over to an area of more low pressure. And then that cooler air sinks back down again and warms up as it does, builds up pressure, and the cycle repeats. And with it creates the precipitation. So driven by temperature and pressure, as advertised. Okay, so these are the currents that are going on in the water, and these are important too because they're moving nutrients around as well. And again, just you get the idea here that the red currents are more shallow, and then the colder ones are deeper. So you get an idea of how the flow is going here. And when you get to the point here where the water starts rising up, that's a key point there. Because that's what they call upwellings. So now the nutrients are coming up as well, and you've got areas with a lot of nutrients. Because those nutrients have been sinking down. Gravity takes them down. The term for that is marine snow. So there's a lot of nutrients on the bottom, and a lot of more nutrients at the top, but maybe not so much in the middle. But in these areas of upwellings, there's all this available at all levels of the ocean. So that adds to a bit of diversity too. So where these upwellings are important and feature into later discussions. Okay, so this is a close-up version of it. And there you go, little flow going on. More aware all the time of the way things work out. So here again are the cells we talked about, and with them talking about some of the diversity of landscapes. So you can see things are kind of we got the rainforest, and as you go away from the equator in either direction, there's a little bit of a predictability as you change in latitude. And these latitudinal changes are similar to what happens in mountains, but more on that story later as well. So there you go. Okay, and you can see areas where the condensation is. We showed where the condensation was. And then areas where there's less condensation, where the air is sinking back down. And there's your deserts compared to your forests, right? Okay, so that's the idea of that one. All right, so these are the things that are warming up the atmosphere. So we're talking about the heating here and the greenhouse gases. We're all familiar with CO2 and H2O. Methane is CH4, and nitrous oxide is N2O. Nitrous oxide. And the greenhouse effect is these gases warming us up, and that's necessary. We need that because we need the planet to be warm, and the question is now, are we enhancing that by human activities? Okay. All right, so let's see. This is the way it works. So we are perpetually given radiation from the sun. It's coming at the planet all the time. And most of it absorbed by the ozone, as you can see. Some sneaks through, and that gets absorbed by the Earth, but that's only a small fraction of it comes through. And then we radiate the heat back off from the Earth as the hot air rises, and then it gets trapped here, and that's the greenhouse effect, where it gets trapped in. And we need it, it's important, but the question is how much of it is good for us, and are we enhancing it to the point where it's not good? Well, it seems to be up for some debate right now of how we're affecting that. But the temperatures do seem to be going up, which in all fairness has happened before. Okay, so this is going to affect the climates, as you can imagine. So mountains, interesting, I said about the mountains before, as you go up in elevation, it's like moving up in latitude, like away from the equator. You're getting from a hotter area to a colder area. The top of the mountains can be cold. But the thing here also is that as the winds come through and the precipitation is coming off of the water, where mountains are generally located pretty close to, the precipitation doesn't get over the mountain. So they have the rain shadow effect. So they're stopped and the precipitation happens there, so there's a lot of moisture. And of course, moisture is needed to have a lot of growth and a lot of diversity. So there's the rain shadow effect. Of course, it blocks it, so at the other side of the mountain, you don't get as much precipitation, and that affects the kind of landscape you're going to have there as well. All right, so another thing is cities. Cities are sometimes called heat islands. They absorb heat, don't get rid of it as well. So there are climates around a city that are maybe a little bit different than the surrounding area. And you might have noticed that if you went into New York City, and it's pretty hot here, and it's a little bit hotter in the city. That's the idea that they call them heat islands. And they're trying to design them with that in mind now, to maybe change that a little bit. But I'll tell you one thing for sure, it's pretty hot in the subway sometimes in the summer, I know that for sure. Okay, so here's a depiction of the rain shadow effect, and you can see again, the winds are coming through, and then they are releasing the moisture, and that's the windward side over here with the rain shadow effect, and the leeward side doesn't have moisture, so you're going to get desert areas and very interesting landscapes, that's for sure. Okay, so I've already mentioned this. The latitude and elevation have a similar effect as you move away from the equator and moving up into the mountains. You have a similar kind of effect, getting colder as you go up, colder as you go farther north or farther south from the equator. So it also is going to affect what's going on, as I said before, is the amount of moisture, the precipitation, and exactly what the temperature is. So here we break it down for you, and this is the different biomes that you can be looking at. So you can kind of figure it out. We got a lot of diversity of biomes here in the United States. So it's pretty fantastic if you get a chance to travel around our country. And also the world. The whole world has got some great biodiversity. Great things to see all over this wonderful planet. But there you go. You can break them down, and we're going to break them down step by step. So there's your introduction, and take a good look here. Okay, so here we go. This is the idea of elevation and what you're looking at. So you could have a tropical forest, and then a deciduous forest. That's the kind of area that we live in. Coniferous is a little bit cooler, and those are more your evergreen trees. And then the tundra, where not much can grow at all. And really amazing that life can exist in those places anyway. So much diversity in landscapes and also in life there. So that's a depiction of as you move up in latitude and or down in latitude and up in elevation. Okay, so again, the idea here are the precipitation and the temperatures. Those are what's going to limit you from what you have. So we got a little bit more of a picture here and the idea of what's going on in the different places. So we have deserts in all these different places, but depending on the temperature that we're talking about, they all have precipitation in common, but they don't have they have different amounts of precipitation. So the temperature and the precipitation are coming into play. And also you can see that with the types of trees that you would be dealing with as well. Okay, desert is a little bit rough. The nutrients take a long time to cycle, but there's life there, and it's amazing the life forms that can exist in the desert. So they have adaptations where they can hold on to the water. We all know about camels, and we have seen cactuses, so they're not as going to lose as much water. Once they get a little bit of water, they're going to be able to hold on to them. Waxy outer coatings that prevent the water from escaping, and animals maybe nocturnal is a good thing, so they won't be out in the heat of the day if it's in a hot desert. And that's it, but mostly they're going to have to adapt to not having a lot of available water. Okay, so for deserts we have, as I was mentioning before, different temperatures for deserts. And they all have, there is life living there, but not a lot of it. And the nutrients and the lack of water are big deals we've already said. So the plants aren't going to grow very fast. or very tall. Okay, so there's a tropical desert, and we're showing some people damaging that ecosystem, but having a lot of fun as well, I'm sure. And these are charts here. And on the bottom, they're going to show the amount of water, and you can see it kind of fills in. And then they've got the temperature line as well. So you should be able to read these things for the different deserts, and you can see the main difference here is, well, they all have low amount of precipitation, but it is the temperature that you're talking about. So in the cold deserts, it'll get below freezing during certain times, and in tropical deserts, you're not going to see that. It's very hot all the time. Also bad at holding heat, these areas. So sometimes you can get really hot during the day, and it cools down dramatically at night. But yeah, very interesting, the type of life forms you can get there. Okay, so grasslands we could talk about as well, and we will. So we have different types of grasslands, and again, it's the temperature that makes them different. They have similar amounts of moisture, and there we go. So the tropical, if you're ever picturing the Lion King or something, that would be the savannas, and gazelles you could picture, and this kind of thing. So those are very hot grasslands. And the temperature ones are more like we have in the middle of our country, the breadbasket, if you will. That's what you can kind of picture as being middle America. That's kind of what it's like. And then there are areas that are so cold, and that's the tundra areas. And so these animals have to be adapted to not living with a lot of with a very colder temperature, so they got to be ready for that. Permafrost is stuff that remains frozen most through the year. It's like soil that remains frozen for most of the year, and then it melts a little bit, but mostly solid. For the it can melt a little bit. But part of the problem with the permafrost is now they're noticing it's melting more than it has before. And of course the argument still comes back, or the debate, and people will debate you on whether humans are causing some of that, but the temperatures are going up. And the thing about permafrost that is concerning there is that it holds a lot of methane. And methane doesn't last in the atmosphere as long as carbon dioxide does, but it does trap more heat. So it's a pretty good greenhouse gas. And then the permafrost gets you involved with a little bit of a positive feedback loop, where you release methane as it melts, which warms up the atmosphere, which now melts more of the permafrost, which releases more methane, and you have a positive feedback loop. And maybe you reach a tipping point where you no longer freeze. The permafrost never freezes. Okay, so these are areas that are colder. And here we go with the grasslands, tropical. You can picture it. There's more like the middle of our country. And all of them beautiful in their own way. And the cold grasslands, also called the tundra. And I guess you should know that the tropical grasslands are called savannas. Okay, so here's one of the things that we're doing, and have done a lot of it in our country as well, is taking all the biodiversity that grows there and trying to grow one crop. So that's something that cuts down on the biodiversity, and that one is definitely anthropogenic. Now, you could argue this as being a negative for the loss of biodiversity, or you could argue it as, hey, we have a lot of people and a lot of people need food. So that's an interesting one there too. But this is why the middle of our country is very, very good for farming. Okay, this is one of my favorite places, is the Chaparral. It's more out in the southwest, and it gets very dry, the air there. It's very different than it is here. Very interesting landforms too, but yeah, nice dry, comfortable climate, but dry is part of it, and when it is dry, it is a big chance for wildfires. And I haven't had a chance to drive near some of those wildfires and get rerouted because of them, and no joke there. So I've driven through the desert while wildfires were going on, or these chaparral areas, not quite desert. And it's really something devastating, and you got to get out of the way. Okay, so this is the idea of it in Utah. Just beautiful if you get a chance to get out there. And now you know about that kind of diversity. Okay, so forests now we can talk about. And again, they have a similar kind of deal going on here, but very different temperatures. So tropical ones, we can picture the rainforests, and it looks like so much biodiversity going on in there. And there's so many plants that are only in a very localized area. The little wind doesn't move things from one area to another, and so you get these species that are only existing in a very small area, and they don't really move around as much. So the soil nutrients don't stay in the soil very long, so they're rapidly recycled through, and actually a limiting factor because they're used up very quickly, and there's not a bunch of them. We are impacting the rainforest in dramatic ways because there are resources there that we like to go after, and so we're have been unsustainable at times, but there's also been some comeback stories in the rainforests, and we get to talk about some of those later on, and that's fun. Okay, so deciduous forests we should be very familiar with. The leaves change in the cooler weather, like they probably are right about now if we're covering this chapter. If you're reading it about the time you're watching this video, I should say. So yeah, we have a good amount of moisture here. That's not a limiting factor for us. And a lot of trees too. And a lot of our area here was covered by trees, but when settlers came over, they cleared out the trees pretty good. We were a lot more trees than we used to have. But we still have a bunch too, and you have seen them, that's for sure. Now, with all the leaves that fall on the ground, lots of nutrients in the soil around here, in the leaf litter. So there are decomposing leaves that happen every year that we can count on, and this is like just sending nutrients right back into the soil. So we have nutrient-rich soil, and that was one of the things when they cleared out the trees around here. New Jersey was called the Garden State because there was a lot of agriculture here, and there still is some. So that's pretty good. That's pretty good stuff for us here. Okay, so evergreen forests, well, they are ones where the leaves don't change, so they're not able to go through the cycle that the deciduous forests are able to go through, and that's the deal on the coniferous forests. Now, some of these get enough rain, and these are ones that are kind of near the coast. We have them up in Northern California, up in Oregon, but they call them temperate rainforests because they get so much moisture during the year. But the trees, because of the temperature, don't look like the rainforest down in by the equator, the rainforest down there. Okay, so there's the tropical rainforest, lots of biodiversity, and there you go. The temperature is pretty hot all year round. Here's us with our fluctuating temperatures, and we're not often below the freezing point, but as you go farther north, you're more apt to be. And that is the deal there. Okay. So here is a little bit of the tropical rainforest, and again of all the different things that are going on. So you got a lot of biodiversity things going on in all levels of this setup here. Food webs happening, and that's what they're showing here. So the ants are going to eat the eat the plants, and the tree frog is going to eat the ants, and the green snake's going to eat the frog, and an ocelot will eat the snake. So there's highly developed food webs and food chains and great biodiversity. All right. Okay, so the idea here too is like we've talked about before with resource partitioning. So you'll find different animals in different parts of the trees, and that's how they get so much biodiversity going on. Pretty fascinating. Never been to one of those rainforests. Maybe some of you have. And if you have, maybe you'll bring some of those stories into class. Tell us what you saw. I heard there's a lot of bugs and big ones too. I'd still like to go. Okay, so here's some of the things. I love these birds of prey. So there's some eagles. All right. Pretty great. High canopy. A lot of competition for the sunlight because they're such a densely put together, fascinating place on the earth. Love to get there someday. Okay, so I've been up to this kind of area, and this is also fascinating. Some trees that are very, very old out there. But here you're in the rainforest. This is in Washington State. So like I said, the west coast of our country. And up toward the north, where the prevailing winds are bringing in a lot of moisture, and you can rely on it. A lot of moisture up there. Okay. Okay, so mountains are important. Lots of trees in the mountains, lots of species that are only living in that mountainous area, so that little thing that's going on. There is a big movement of what's going on with water here. We rely on the water as it melts from the water that melts, it freezes and then it melts, and then you get the flow in the river. That flow from the river brings nutrients down. You can get agriculture at the bottom of it. All kinds of things are being moved through there for you. If this water flows down to the sea, it's even going to affect the sea levels. That is one of the concerns, that these glaciers are melting and not coming back, and as they melt off the land and into the water, they're affecting the sea level, so that's something to be thinking about as well. There's a lot of movement through here, different temperature gradients, and lots of stuff going on. And again, these endemic species are only going to be in that mountainous area. Another fascinating part of the world. Fun to go up these mountains. This is a place that I have been to, Mount Rainier National Park in Washington State, and just amazing to stand near these mountains. Grand Tetons are another great one that I've been to, but just amazing. Smoky Mountains, a lot of mountains. Great stuff. Okay, so what have we done to these different places? Now we understand what goes into it with the precipitation and the temperatures, and what do we do as human beings? Some of these things we can argue about, and what the human causes are, like the temperature change that we're experiencing right now. But some of these things we've got figured out that we have done. So how have we done this? For the deserts, a big part of it, like I said before, is you're doing damage to it. The nutrients don't cycle too well. Now you're compacting them down. You are in trying to grow things there, you're bringing in salt water, so it's getting even salter. We've also drawn the water out underneath them, and also trying to do some mining in there as well. Building on the deserts, that disrupts things. So Las Vegas is built on the desert, and there you go. For the grasslands, like we talked about before, well, we have turned this over to our uses. We have a lot of people to feed, so that's important, but that is changing what the grasslands are all about, and all that biodiversity. As we're clearing it, we're releasing CO2. If we're burning the grass, that's one thing that we could be talking about. Causing soil erosion also by farming practices that aren't that great. That's another one we could talk about. We could talk about all the amount of fuel that has to go into agriculture. That's one thing we could really be concerned about. All the amount of fuel that goes into raising the cattle that's involved. So we've done a pretty good job here, but kind of have to for our uses. For forests, which we get to talk about more later as well, we have in the past cut them down pretty indiscriminately, and that's the deforestation. It can come back in time, but we have to kind of be smart about that if we want them to. But the lumber is useful, and the things that we can find after we go in there are useful as well. So there's an environmental and economic concerns that have to be taken into account. Okay. And if we make into tree plantations, it's obviously monoculture there. So it seems the off-road vehicles are implicated in a lot of these things as well, banging up the landscape. But it can be fun, that's for sure, recreational. Okay, so mountains as well. So some places we've cleared off the mountain tops completely to go mining for what's in those mountains, which is valuable to us. People like to go up in the mountains, so there's a lot of travel in there. A lot of, we said before, the forests are in the mountains as well. And looks like the off-road vehicles, again, are doing some damage. Okay. Air pollution. All right, so that's the effects that we've had. And that brings us to the end of this chapter. So hopefully that introduction to these diversity of landscapes and the climate and what drives these things was helpful. Look forward to seeing you back in class. Thanks for watching.